2 into 10 to the power minus 12 second can be written as 2 picosecond, as the prefix for 10 to the power minus 12 is pico. So these are the 12 prefixes for SI units. Now we'll see what are derived SI units. These are the units for derived quantities, and they consist of the base units, that is fundamental units, and various combinations. For example, the SI unit for force is Newton, and as we know that force is nothing but mass into acceleration. So for mass we have the fundamental unit kilogram, which we write as m. Similarly, acceleration is nothing but meter per second square. So meter is again a fundamental unit which has dimension of L, and second square is again a fundamental unit having the dimension of time. So this is the dimension of Newton. So as we have seen here that the Newton, which is a SI unit for force, it consists of 3 base units, that is that of mass, length and time in various combination. Similarly, if we take example of joule, now joule is nothing but the SI unit for work, and we know that the work is nothing but force into a distance. So force, we have already seen that force is nothing but m L into t to the power minus 2, and distance is again a SI unit, again a base unit, which has a dimension of L, that is the dimension of length. So here we have the dimension of joule as m into L square into t to the power minus 2. So again we have a derived SI unit, in this case joule, which is the SI unit of for work, and this derived SI unit it can be expressed in the various combination of base units, that is in this case mass, length and time. Now we'll go through the various definitions concerning dimension. The dimension of a physical quantity is the power to which the basic unit should be raised to express its derived unit. So for example, the unit for force is Newton, and force can be defined as mass into acceleration. Now the dimension for mass is m. Now acceleration can be defined as meter per second square. So the basic unit for meter is that of length, that is L, and for time it is t. So here we can say that the dimension of force with respect to mass is 1, with respect to length is again 1, and with respect to time it is minus 2. Now the dimensional formula is the expression representing the dimension of a physical quantity. So here we can say that the dimensional formula for force is ml t minus 2. We can write it as inside a single square bracket ml t minus 2. So this is the dimensional formula for force. Now here the force is a derived unit. The dimensional formula for a basic unit, as we have already seen, that for mass is nothing but m, for length it is L. So these are the basic units, and for derived units, as we just saw, for force the dimensional formula was ml t minus 2. Now the dimensional equation is the equation obtained when a physical quantity is equated with its dimensional formula. So for example, we have a equation in kinematics, that is v is equal to u plus at. Now here if we represent these physical quantities with its dimensional formula, we can write v is equal to meter per second, that is L into t to the power minus 1. This will be equal to u is again velocity, which is L into t to the power minus 1. Now acceleration is meter per second square, that is L into t to the power minus 2 into time. So the second part will again become L into